Hi guys, okay, this lesson we're going to look at surface area of prisms and cylinders. So basically guys, surface area is when you find the area of all the faces on the surface of a 3D shape and you add them together. That's the surface area. And that's the key point here. Find the area of each face, then add together. For a cylinder, it says, be careful here guys, are you looking for the total surface area or the curved surface area? And this is in the formula sheet at the start. The curved surface area is obviously the curved part. You can think of it like the label of like a can of beans or something like that. So just be careful what the question's asking. Okay, so we basically have to break it up into the different shapes that it is. This is a prism. It is a triangular prism. How many faces are there? Well, we have to figure this out. There's one at the front, one at the back, the two triangles, that's 2. This guy here, which you can see, is 3. There's one at the bottom, is 4, and then there's one over here, which is 5. So there's 5 faces. Let's start with the triangles. Now we might even call them, guys. I'll call this A. We'll call this one at the back B. This one C. I'll call this one here at this back D. Let me actually put D over here. So in behind there is D, and then we'll call this one E, just so it's nice and clear. Now the reason I haven't put it here, guys, is because to find A, we need this height, which I don't have. Now I can find it easily. Again, guys, you'll see Pythagoras appears everywhere. Using Pythagoras, okay, I'll do it very briefly here, guys. Pythagoras' theorem, h squared plus 8 squared equals 10 squared. H squared is equal to 100 minus 8 squared. 100 minus 64 is 36. H is equal to 6. So that height is 6. Okay, so let's just kind of break them up because we'll do them in pieces. Area A is, it's a triangle, so it's just a half. Base, which is 8. Height, which is 6. Half base times height, 4 times 6 is 24. I won't put centimeter squared until the end. Okay, B is the same. It's just 24 because it's the exact same triangle. It's a prism. That's what a prism is. Okay, C is this guy. So this is a rectangle. And you'll notice this, guys, with prisms is all these faces are always rectangles because, well, just because of the way a prism works. So this one is going to be 25, it's just length times width, 25 times 10. 25 times 10 is 250. Okay, D is at the back here. It is 6 times 25 because 6 times this way and 25 across. So I'll just do 25 times 6. That's 150. Use your calculator if you want. And finally, E is the one underneath. It's going to be this 8 times 25, or 25 times 8, which is 200. Okay, then the total surface area, TSA I'll call it, is add these all together. We get 250, 350, that is, sorry, 3, 4, 5, 6, that's 600, 648, so it's 648 centimeters squared. Okay, part 2. Question 2. So we have the curved surface area. So I'll call this, guys, curved surface area. The formula for the curved surface area is this. It's 2 pi r h. 2 pi r h. That actually comes from the fact when you open up this, if you think of it like the label of a can of beans, if you open up the label, it's actually a rectangle with length, circumference, 2 pi r, and width, the height. Anyway, you don't need to know that, although it's something that's nice to know. You just know there's a formula. So it's 2 times pi times radius, which is 5, times height, which is 15. And this is equal to 2 times 5 is 10, times 15, 150 pi. So that's the curved surface area. The area of the circle, is equal to pi r squared. So it's just pi times 5 squared, which is equal to 25 pi. So the total surface area, TSA is equal to, and again, check what he's asking, but is equal to the curved surface area plus one circle, which is 25 pi, plus another circle, which would be exactly the same, so another 25 pi, and that gives me a total of 200 pi. Now, that's centimeters squared, and obviously, guys, you can put it to decimal places if you want. But yeah, just be careful, guys. Is he asking for the total surface area, the curved surface area, and even he could have a situation with a cylinder that is closed at the bottom but hollow at the top, or he's taken the lid off the top, and we're not going to count that. So again, always just be careful with the question. Okay, so that's kind of the basics, guys. I am going to go to a past paper question just to show you kind of what we're dealing with. So question 17. The diagram shows a solid prism. So it's a prism, but this time the face, the face of the cross section is a trapezium. So we just need to be careful here, guys. Trapezium, let's call this face A. So A is the trapezium, B is the back, B is the back, B. I'll call this guy C. I'll call the top D. I'll call this guy over here E, and then I'll call the bottom F. So now, guys, we do actually have 6 faces. So just be careful, and guys, the A refers to the trapezium in the front. Maybe actually I'll put the E over here, guys, just so we're clear that this means the E means the kind of side face there. Okay, so let's do them one by one. A is a trapezium. The area of a trapezium is a half A plus B, so the two parallel sides, 37 plus 28, because of this guy, this is 28 here, guys, because that's 28 and they're the same length because it's a prism. 37 plus 28 times h, which is 20. This, guys, is in the formula sheet at the front. Use your calculator. 20 over 2 is 10. This plus this is 65. 65 times 10 is 650. Okay, so this, guys, is 650. Feel free to use your calculator. B, a bit like the other one, guys, and it's always the case for the prism, because there's 2 cross sections, they're both going to be the same. So the front one is 650, the back one's 650. C, that's the side face. Okay, now this one is actually going to be a little bit difficult, guys, because I don't have this length here. Okay, now he says the midpoint of BC is vertically above the midpoint of AD, so BA and CD are equal, right? So what I'm going to do is I'm going to draw a line straight down here, and you're going to see Pythagoras is going to appear again. I know this length, guys, is 20. This length, though, I don't actually have yet, but I can figure it out. Look, this is 28. I'll actually draw another line down here, guys, just so you can see it. This is 28, and this is 37. So what's left? Well, there's 9 extra here. This is 9 bigger than this, which means we need to put 4.5 there. That's 4.5. And this would be 4.5. If you think about that, guys, that 4.5 plus 37 plus 4.5 gives me, sorry, that's not actually how to think of it. 4.5 plus 4.5 plus this 28, which would be here, would give me the 37. Okay, so now I'm going to find this length here. Let's call it x. Now I'm going to use Pythagoras. Let's do it down here. I can say x squared equals 20 squared plus 4.5 squared. X is equal to the square root of that. So it's the square root of 20 squared plus 4.5 squared, which is 41 over 2, or 20.5. Now that's quite a nice number, guys. So that's given me hope. Okay, so x is 20.5. So C is 24 times 20.5 because it's x times 24.5, which is equal to, let's do it, that times 24 is equal to 492. Okay, so that's 492, this one, C. Now guys, E is the same, but I'll get to E after, but it's the same as C. D is easier. It's just 28 times 24. That's 28 times 24, because that's 24, that's 28, it's a rectangle. 28 times 24, 28 times 24 is 672. And then E, sorry, there's two left, guys. E is, as I said, the same as B. So this, or sorry, same as C, which is 492. And then F will be different, guys. F will be different. It's the bottom, but it's 37 times 24. It's not that difficult. It's just base or length times width. It's a rectangle. 37 times 24. 37 times 24 is 888. Okay, those are my six faces. So surface area is equal to, and I just need to add all of these together. So 888 plus 492 plus 672 plus 492 again plus 650 plus 650, and I get 3844. 3844 centimeters squared. Okay, that's it, guys. That is question 17, and it's surface area. Key points, guys: get the area of each face, add them together, make sure you read the question carefully, and that is it.